Hello class, welcome to another video for this course. In this video, we are going to start chapter 5, trigonometric functions. And we start this chapter by studying the first section, section 5.1 circles. And the reason is that we need to, because trig functions are based on circles. So we need to review circle and what we know about circle, and even study circles in more details, so that we can have a strong foundation that we can use on it for the rest of the chapter to build these trig functions. So I know some of the topics in this section might be repetitive for you, but it's very important to refresh our mind, as these are gonna be used for the rest of the course. So let's start by Pythagorean theorem that I am sure you have heard about it. It's a statement about a right triangle. So when we have a right triangle, then the sum of squares of some of the squares of legs of the right triangle will be equal to the hypotenuse of the triangle. So in other words, if you have a right triangle and the legs are labeled with A and B, and hypotenuse is labeled with C, then the relationship between the size of each one of these sides can be expressed as A squared plus B squared is C squared, or sum of the squares of legs is the same as hypotenuse squared. Okay, so let's use this theorem, this well-known theorem, in order to derive a distance formula between 2 points. And let's start by this example. So suppose you have 2 points in the plane, and you want to see what is the distance between these 2 points. So this example gives us 2 points on the plane. It's -3 and 2, and the point 2 and 5. And the question is, what is the distance? What is the distance between these 2 points? Okay, let's first plot these points on the plane. -3 and 2. So that's gonna be this point, and 2 and 5. So this is 2 and 5, right? It's gonna be this point. And the question is, what is the distance? So we can draw, look, this line, the straight line that connects these points, whatever is the size of this side, it's gonna be the distance. Okay, so I hope that's clear, that the distance between these 2 points, so maybe I also put the points. So this is the point -3 and 2. This is the point 2 and 5 on the plane. Then the red line, whatever is the value of the red line, is the distance between these 2 points. So the question is, what is the value? What is the distance between these 2 points? One way to find the size of this line or the distance is to create a right triangle. Look, because you can do this. Look, you can, suppose you have this, right? Right. So you can draw this, right? Create this right triangle. This is a right triangle. And so what are the values of the legs of this triangle? So this is 1, 2, 3, 4, 5. So this side is 5 unit. What about this side? This is 1, 2, 3. This is 3. Okay, so now we can find the distance by using the Pythagorean theorem, because we know that when we have a right triangle, then the hypotenuse square is actually a square, the legs square. So it's going to be 3 square plus 5 square. The relationship between the sides of a right triangle is that the sum of the legs square, in this case 3 square plus 5 square, is the same as hypotenuse square. So in that way we can calculate that. So 3 square is 9, 5 square is 25. So this is gonna give us 34. So the distance is, but that, please pay attention that that's distance is square. So the distance between these 2 points is square root of 34, which you can use a calculator to estimate that value. So the distance is square root of 34. So from here, we can, so the reason that we actually did this example is to come up with a formula for the distance between any 2 points. Look what we did in this question. So in order to derive the distance, we had the square roots of 3 square plus 5 square, right? So, okay, what is 3 square, 3 and 5, the value of 3 and 5? So actually 5, look, so I'm gonna draw it here. So because in this example, we saw that, in fact, look, in fact, the distance, right? We obtain the distance by taking the square root of 3 square plus 5 square, right? So if I can come up with what is 3, what does 3 represent in this question, and what does 5 represent in this question, then we can come up with a formula. Look, what is 5? 5, the value of 5 is in fact the distance between 2 and -3. Look, 1, 2, 3, 4, 5. So 5 actually shows the number of units between these two x values, right? So this is the x value for this point, and this is the x value for this point. So, so in other words, we could also say that the 5 here is 2 minus -3, because this is going to give us 2 plus 3, which is 5, right? So it's like if we subtract, so it's like finding the distance between these two x values. Let's call them, this is the first point, right? So if this is the first point, let's call its x value x1, its y value y1. Let me use another one, because every point has x and y coordinates, right? And let's call the other point, the second point, P2. So its x value is gonna be x2. It doesn't matter which one you call first or two. You can go either way, right? So let me show you. And this one is x2. So I named one of the point as 1, the other point as 2. Then how can we come up with 5? 5 can be written as 5 can be written as 2 minus minus 3. So 2 plus 3, which is 5. So 2 is x2 minus negative 3 is x1. So how about, so in fact, 5 came out of subtracting x2 and x1, right? So 5 came out of this subtraction. What about 3? Look at 3. 3 is the same as this. Look, the distance between these two y values. What is the y value here? 2. What is the y value here? The height is 5. What is the difference between these two heights? 5 minus 2 gives me 3. What is 5? It's this y value for second point. 2 is the y value for the first point. So 3 is in fact the difference between these two y coordinates. That's it. We came up with the formula for distance. So we can say that when you have 2 points, so when you have 2 points, when you have 2 points, any point has coordinates, right? Such as x1, y1. I mean, any point has 2 coordinates, x values, y values. Then if you want to find the distance between those 2 points, the distance between those 2 points, you can take the square root of, find their difference, find the difference in their y coordinate, square it, find the difference in x coordinates and square it. So that's it. We came up with a formula for distance between any two given points. It's the square root of sum of squares of the difference in their coordinates. That is also written in this box. So the distance between 2 points, here points are represented with their xy coordinates, can be calculated by this formula. And basically we use this example to show that where does this formula come from. Okay, now what's the reason that we discuss about distance? Because that gives us a way to come up with a formula for a circle. So I hope you know what is a circle. Circle is a shape that it has a center, and any point on this shape has the same distance from the center. So for example, in this picture, you see that this is a circle. Why? Because any point on this object, there is a center. Center is H and K in this picture. And then any point on this object has the same distance from the center, which is r, or in other words, radius. It's called radius of the circle. Now, look, we can come up with a formula for circle because now we know what is distance, right? Look, what is a circle? What is a circle? What is the definition of circle? So circle is in the plane. So suppose we have, this is the plane, this is the coordinate system, and then you have a circle, right? Like, suppose you have a circle like this, right? The circle, what is a circle? There is a center, whatever is this center. Suppose it has the coordinates of H and K. H is the X value, H is the X value, K is the Y value, right? And then any point on this circle, any point, so any point that you pick on the object, it has the same distance from the center. So if the distance, for example, you pick this point on the circle, it has a distance of r R is just a label from center. You pick another point, it again has the same distance from the center. You pick another point, it has the same distance from the center. So it's all the points that stand on the same distance from the circle. So now, because we learned about distance, let's find the formula for an equation. So pick any point, X and Y. I mean, you pick any point, we know that point has X coordinate and Y coordinate, right? Okay, so we know that the distance between points, what are the points? One point is X and Y, and the other point is the center. The center is H and K. So this is the center. What is the formula? We know that the distance between these 2 points is the square root of their X coordinate, the difference in their X coordinate square, plus the difference in their Y coordinate square. And it happens that when you have a circle, this distance is always the value of radius. That value is called radius. So this distance is R. So when you have a circle, that distance is R. So that's it. This gives us a formula for circle. This is a formula. This is a formula. This is a formula for a circle. For a circle centered. What is the center? Centered at, the difference between their X values, Y values. Okay, centered at H and K with radius R. Okay, so that's it. We came up with the equation of a circle. By the way, so this is it. This is it. Now you can express it also by making a square of both sides. So let me show you that. So you can either say this is, use this version of the formula, or if you prefer to do not have a square root, then square both sides. R square is going to be R square, and when you square the left side, you get rid of the square root. So it's going to be this. So it's just the same thing. It depends on which version would you prefer to use. The top format, this format has the square root. The second format comes with without square. So as you can see, radius is just can be obtained by distance formula, and then if you like, you can square both sides of this equation, and then you can say this is the equation of a circle, and the center is H and K, and radius is R. And one point is that please pay attention that this is not a graph. The circle is not a graph. Why? Because when you have a circle, look at the graph of circle. So suppose you have a circle, right? This is a circle. This is not a function. Why? Because it fails the vertical line test. If you draw a vertical line, then it intersect the graph at 2 points, at more than 1 point. So it fails. It fails the vertical line test. Therefore, circle is not a function. So yes, we draw the graph. Yes, this graph has a formula, but it's not a function. Just keep that in mind. Okay, so now let's for a little practice the formula of the circle. The question says that write an equation of a circle with this center and radius. So center and radius are given, and the question is come up with the equation of the circle. So what is the center? Circle centered at point, a circle that is centered at point -3 and 2, and radius 4. Okay. So what is the formula of a circle? It's r squared is x minus h squared y minus k squared, in which h and k are the center, r is radius, right? This is the formula of circle. So in this question, r is 4, so it's gonna be 4 squared, x minus h is -3, and k is 2. So I just substitute the value for center and radius into the formula. And then let's simplify. So this is gonna be 16. Oops, I'm sorry. Because I use the, Because I use this version, because I use the square version, r square, so I should not put so I'm using this version. R square. So there is no square root. When you put r square, then there is no square root. Okay, so now let's simplify. So this is gonna be x plus 3 squared, y minus 2 squared. That's it. This represents the points on the circle. X plus 3 squared, y minus 2 squared, 16. Yeah, that's it. So this is the equation of the circle centered at -3 and 2 with radius 4. Write an equation for the circle graphed here. Okay, so let's see, what is the center? I just need to know what is the center, what is the radius. So it seems that the center is origin, radius is 1, 2, 3. Center is origin, so example 3, based on the graph, center of the circle is origin, 0 and 0. Radius seems to be r, 3. So r squared is x minus h squared plus y minus k squared. That is the formula for the circle. R in this case is 3, so it's going to be 3 squared. H and k are 0 because the center is origin. So it's going to be 9 x squared plus y squared. That's it. X squared plus y squared equal 9 is the equation of this circle. X squared plus y squared equal to 9. So now let's talk about points on a circle. For example, find a point on a circle of radius 5, center at this origin with value at the origin with an x value of 3. Okay, so let me first draw it to give you a picture of what this question is talking about. Example 4. So the question says we have a circle, right? I'm going to draw the circle. It's going to give you a good idea. Radius is 5, center is origin. Okay, so we have a circle centered at origin, radius 5. 5, 5, 5, 5. So it's gonna be roughly something like this. right? Center is origin, and radius is r. The radius is 5. Okay, now the question is, find a point on this circle with an x value of 3. So if the x value is 3, 1, 2, 3, what is the, okay, it's gonna be this point. So it's asking me about this point, that x value is 3. The question is, what is this point? What is the y value? So the question is asking me about the y value of this point. Okay, so the question is, what is the y value of this point? So let's go back to the, again, formula equation of the line. So what is the equation of a circle? So equation of this circle, what it is. So what is the general formula for equation of a circle? It's x minus h squared y minus k squared is r squared. In this case, center is origin, so it's going to be x minus 0, y minus 0, and radius is 5 squared. So it's going to be x squared plus y squared equal 25. That's the equation of this circle. Now the question is, what is the y value when x value is negative 3? Please pay attention that, in fact, when x value is 3, we have 2 points. One point is here, and there is also this point. You see? This point, there are 2 points on this circle that both of them have the same x value, but they have a different y value. So the question is, find those points. So let's use the equation of line, because we know the relationship between x, y, and r. Now we know the relationship between x value, y value, and we just know that the x is 3. So substitute 3 into the equation, right? And then solve it for y. The rest is algebra. So 3 squared is gonna be 9. So y squared is gonna be 16. So y is gonna be positive negative square root of 16, which is positive negative 4. That's why we have 2 points on the circle. You see, one of them is the positive. So one of these, you see, there are 2 y value, positive and negative 4. So which one is positive 4? Of course, the one in the top. So this one has y of positive 4, because you see the y value is the positive one, and this one has the y value of negative 4 because the height is down here. So what are the points? So this point is the point of 3 and positive 4, and this point is 3 and negative 4. So there are 2 points on this circle with the same x value. That's why circle is not a function. As you can see, for one input value, the input value of 3, you get 2 output values. So that's why this is not a function. It's not unique. But anyway, we have the equation and we can calculate the corresponding y value for a given x value. So there are 2 points on the circle with x value of 3, 3 and 4, 3 and negative 4. Next example, find the x-intercept of a circle with radius 6, center at point 2 and 4. So let me first draw this circle. So there is this circle, and the question is find the x-intercept. You don't have to draw it, but I like to draw it because, it gives us a visual perspective of the question. So this is example 5. What is the circle? It's a circle centered, radius 6, centered at 2 and 4. Circle centered at point 2 and 4, radius 6. Let's see. So this is X, this is Y, 2 and 4, 1, 2, 3, 4. So this is the center, right? This is the center. Radius is 6. So let's see if I go, I need a space. So 6. Okay, so this is like 4, right? And then I need to come down to 2 units. Okay. And then I need to go up 6 units as well. 6 plus 4 gives me 10. Suppose this is 10, I should go over here. Okay, so roughly we should have a picture like this. I know my graph doesn't look like good, but that's the best I can do here. So you have a circle with center at 2 and 4, radius. So suppose this is radius, this shows the radius 6, R is 6. Okay, what's the question? Find the x-intercepts. X-intercept, so I see that the graph intersect with x-axis at this point and this point. So there are 2 x-intercepts. The question says, what are these 2? Okay, so the circle cross x-axis. The question is find these 2. Okay, so let's first write the equation of this circle. So equation of this circle, equation of this circle. In general, we know that x minus h square, y minus k square equal r square is the equation of the circle. In this case, the center is 2 and 4, radius is 6. Okay. So that's the equation of this circle. If you want, I can simplify it a little more. So it's going to be x minus 2 square, y minus 4 square, 6 square is 36. Okay, so that's the equation of this circle. Now, we want to find the x-intercept, right? So what is the characteristic of these points? X-intercepts. So the question is, in fact, what is this x value, right? What is this x value? What is this x value? So what is the characteristic of this point? It has some x value, right? But the y value is 0, right? So we know that we don't know the x, but we know that the height is 0. Same here. We don't know what is x, that's a question mark, but we know that the height is 0 because it crosses x-axis. So we know that y is 0, right? So we just substitute 0 into the equation of this circle. So if you substitute 0 into this equation, then you can solve it for x, because we want to find the x value. So we want to solve this equation for x value when y is 0, height is 0. Okay, so it's gonna be x minus 2 square. This is gonna be negative 4 square, 16, 36. Now subtract 16 from both sides. So 36 minus 16 is gonna be 20, right? Right. So x minus 2 squared is 20. So x minus 2. Now take the square root of both sides. Positive, negative, square root of 20. So x is positive, negative, square root of 20. When you add both sides by 2, you get this. So there are 2 points. Look, there are 2 points which which also match our graph. One of them is positive, this one. So this x value is positive square root of 20 plus 2, and this one is the negative one. Negative square root of 20 plus 2. Okay, so these are the x-intercept, and this is the bigger picture if you want to see the whole thing in a big picture. Okay, so the question was, for this circle, find the x-intercept. So we first wrote the equation of this circle, and then we said, okay, x-intercepts are those values, are those points that has the height of 0. Y value is 0, so we substitute 0 into the equation of the circle, and then we solve it for x. And as you can see, we came up with 2x value, which match the graph. And you can see that here. By the way, in your textbook, square root of 20 is simplified. You can leave, in general, you can leave your answer either as containing a square root of 20, or if you want, you can simplify a square root of 20. Do you know how it is simplified? If you want to express your answer in a more simplified way, just simplify a square root of 20. Because 20 is 4 times 5. So this is going to be a square root of 4 times the square root of 5, and then a square root of 4 is 2. So you can also express your answer in this format, saying that x is positive, negative, 2 square root of 5 plus 2. But it doesn't matter. You can either say square root of 20, or you can express that 2 times the square root of 5. See, both of them are the same thing. Okay, what else? Find where the line intersects the circle. Okay, so we have a line, we have a circle, they intersect at how many points? I don't know, but okay, graphically, let me draw that graphically, because I want to give you the picture. So this is example 7. So what is the circle? The circle is x minus 2 square plus y square equal 16. So because from here, okay, I'm gonna compare it to the general formula, general equation of a circle, right? This is the general equation, general formula of circle, right? So what is this? H and K are the center. H and K is the center. Center is H and K, which is in this case 2 and 0. So it's 2 and 0. So this circle has a center of 0, and R is 4 because R squared is 16. So R is 4. Square root of 16 is 4. Okay, so this is a circle. Centered at 2 and 0. So 2 and 0 is the center, right? This is X, Y. Radius is 4. 1, 2, 3, 4. 1, 2, 3, 4. Negative 4. Okay, so it's gonna be something like this. Sorry, 1, 2, 3, 4. Okay. So it's gonna be something like this, right? Okay, so radius is 4. radius is 4. And the question is, now you have this circle, where does the line of 4x intersect this circle? 4x, so 4x is gonna be this line. I know at 0 it's 0, at 1 is 4. Okay, so once you have 2 points of a line, you can connect them to draw the circle, to draw the line. So if you connect them, you see that they intersect at 2 points. See? So there are 2 intersection points. One is here. Maybe I use another color. The intersection is right here and right here. You see? So the green line, but let me name it. The green line is the line of this, has this equation 4x. The textbook says, look, it says the line of 4x. So the green one is the line for y equal 4x, and the orange one is the circle. Graphically, we can see that they intersect at 2 points. The question is, what are those 2 points? That's it. So the question is about this point and this point, these 2 intersection points. So we have the equation of the circle. Let me put that in the graph as well. It's x minus 2 squared plus y squared equals 16. So we have the equation of the circle. We have the equation of line. Let's see how we can find these 2 intersection points. So we are looking for 2 points. What do they have in common? How can we find these points? Look, what we are in fact looking for is some x value, right? For example, for this point has some x value and some y value. But whatever is, look, whatever is this x and y value, so it has some x value and some y value. Whatever is the coordinates of this point, it sits on both. The point sits on the line and also on the equation. So whatever value is the x value and y value for this point, it should satisfy the equation of the line and also the equation of the circle. Or in another words, how can I say? So there is some x value and y value. There is a unique x value and y value for this point. Do you see that the y value, look at the y value. Do you see that the y value, the height of this point, is the same value for the circle and line? So that means at this point, at this purple point, the circle and line share the same height for this x value. So at this x value, circle and line has the same y value. So for that reason, because they have, maybe I write this down. So at point x and y, and what do I mean by x and y? This intersection point. Maybe I should say at the intersection point, at the intersection point, which we said it has some x value and y value, circle and line, the circle and line share the same y value, share the same x value, y value. share the same y value, right? And x value. So that means, what is the y value? What is the formula of the y value for the line? It's 4x, right? So that is this. So that means because it has the same y value, that means, so this satisfies this equation as well. Because if you think about line, the y value must be 4x, right? What does line set? It says when you give the x input, the y value is gonna be 4x, right? And what about the circle? The circle says that the relationship between the x value and y value at that point is this equation. But because they have same y value, so it's the same at that specific x value, at that intersection point. So because the y value is 4x from the line, that means it should also be held in the circle, okay? Because they have same y value at that intersection point. So I can substitute the 4x from line as the y value into the equation of the circle. And then I have one equation, one unknown, so I can solve it for x, you see? Now let's solve this for x. So it's gonna be x minus 2 squared for x squared. So let's square, because we want to square it, because we want to solve it for x, let's simplify them. This is gonna be x squared minus 4x plus 4 plus, so this is the first one. This is gonna be 4x is 16x squared equals 16. Now let's simplify. X squared plus 16x squared gives me 17x squared minus 4x plus 4 minus 16 equals 0. This is just algebra. What happened? Oops. Sorry. So minus 4x minus 14 equals 0. Okay, then we need to either factor it or use the quadratic formula to solve it for x. So let me see, 17x squared minus 4x minus 12. Oh, yeah, minus 12. Sorry, I said 14. Minus 12. Minus 12. Then I think we use the quadratic formula. Yes, this is the quadratic formula that we learned previously. So either you can use the quadratic formula and express the x value as with the radical format, or you can use your calculator and approximate it. So when you solve this equation, you end up with two x values. One with a positive sign, but with a negative one. Approximately one of them is positive 9666, which is gonna be this one. I'm sorry, it's gonna be where did the whiteboard go? Oops, where's the whiteboard? So something is up with the my whiteboard. I'm sorry about that. Okay, so but anyway, you saw that there were 2 points. I think you remember from the picture, you saw that there were 2 points that the line and circle intersect. Let me see if there is a picture here. No, there is no picture in your textbook. But I draw a picture that there was a circle, there was a line, and they intersect at, yeah. Was it here? I think so. That's what I showed you guys. It's right here. Yeah. So as you can see, this circle and the line intersect at 2 points. And one of them is the positive one, almost positive 0.966. That is gonna be this x value. And as you can see from the graph, one of them has the negative x value, and that's gonna be this one, negative 0.731. Right? So that's it. We found the intersection points. And if you like, you can evaluate the function. You can like use the 4x in order to evaluate their height value, and then express the points. The line intersects the circle at these 2 points. But the idea was that, what was the idea? The idea was that, okay, you have 2 objects, a circle and a line. They intersect at, graphically, you can see that they intersect at 2 points. Now, since we have the equation of each one of these objects, we have the equation of line, we have the equation of the circle. When they intersect, these 2 equations intersect, meaning that, okay, if you're looking for those x value, at those intersection point, for those x value, they share the same y value. That's why, because those y value, those outputs are the same. So you can give the 4x is the output for one of these function. You can just, sorry, circle is not function. 4x comes from the function of the line. You can just substitute into the y value for the circle into the equation and then solve it for x. And in that way, you can find the x values corresponding to these intersection points. Okay, that's all. I think that was just perhaps mainly a refresher. Perhaps you learned them in past, so it was either a refresher for you, or if anything was new. I encourage you guys to dip into the discussion of a circle and practice some of these questions. And the homework problems for this section meant to refresh your mind and prepare you for the upcoming topics. Thank you for watching this video. That's the end of this section. I'll see you in the next video.